Hello everyone. In this video, we are diving into one of the most fundamental data structures in computer science, and that is the linked list. Unlike arrays, where elements are stored in a contiguous memory location, linked lists store elements in nodes that are scattered across memory. So now what is a node? So the node consists of two parts. One is data and another is a reference or a pointer to the node itself. Okay, we called it as next. So why we have a pointer of the same type, like the same structure type or a class type? Because this will give a chaining effect. So as linked list store the nodes in a scattered memory location, so we need to chain them up or knit them. So that's why we need such kind of data structures. And these structures are called self-referential structures. So let's create a sample linked list. Let's say I want to store a linked list or I want to create a linked list that contains these four data 1, 4, 9, 16. So let's create nodes. So I will be needing four nodes and each node has two parts, data and a node pointer or a reference. So let's fill with the data 1, 4, 9 and 16. So let's say this node has an address 100 in a memory, this 200 it is at 300 address, and the address of the last node is 400. So how you can chain them up or link them up? So the node part or the next part contains the address of the next node. So it contains 200. Similarly, it will save the address 300 and this node have 400. The last node address, like, it will point to the null. So this indicates the end of the linked list. Okay. And that's how these nodes are linked together. Usually we say our first node as head and this head pointer contains the address of first node, that is 100. So this head is here. So this is a pictorial representation of the linked list that contains four elements 1, 4, 9 and 16. Now I will be covering few operations like how to find the length of the linked list, how to insert an element, and how to delete. So just to give a very basic idea how the code works, I start with the length function, like how you can implement a length function for a linked list. So let's say I have this linked list. Now I want to find the length of this linked list. So what I can do is, let's say I will take a current pointer of type node and this will point to the head pointer. So we will start with the head and we will traverse the linked list, each node one by one and count the elements. So until this current is not null, we are going to add the elements. So let's say I have a count variable that is a counter. So the pseudocode will be like while this current node or the head node this current node is not equal to null. Okay, so this is our condition where the loop will stop. So here, like when we are here, we are done with the counter. So what we are going to do is we are just going to do the count plus plus. Now, what do you think? What is going to be the next step? Like we are starting with the head. Now we count this node and we see like current is not equal to null. So current contains the head and it is 100 memory location, so it is not null. So we increment the count. Now the next thing is we need to move the current. So current is pointing here. Okay. Now current is equal to current next. So this is how you are going to move to the next node. So I will draw a table here. Like for the first iteration, count is 1. And now when we execute this condition, the current will move here. Okay. It again check current is not equal to null because it contains a memory address here that is a 200. So it will go into the increment the count as 2 and now the current will move further. Current is equal to current next. So what is the current next here? 300. So this will jump to the 300 position. Okay. So now it again goes here at the testing condition. So current is not equal to null. It's true. It will increment the count and again execute the current is equal to current next. So now we are at the 400 location. So is current equals to null? No. So we are going to increment the count. Now what I'm going to say is current is now here at the last one. It is here now. And now you are going to execute current is equal to current next. So what is the current next here? So current is here, current next is null. So it again goes here. Now it will come out of the loop. So because now it is equals to null. So there is a it will come out from here. It will break here. Now what is the count? It is 4. So that's how we calculate the length of a linked list. So I cover in detail because every operation you are going to do, every time you are trying to analyze the operation, first draw the drawing, like you draw everything, you draw the notes and see what do you want to do, like while inserting element or while deleting. So I will show you in this video like how you are going to insert the element, delete the element, and I will be showing and drawing each and everything for better understanding. So let's start with the insert operation. We will start with the insert. So let's start with the insert operation. Uh, we will see insertion at a different positions in a linked list. So how to insert a node at the head position or start of the linked list, how to insert the node at the given position, or if you provide any uh, particular node with a specific data, uh, so we can insert on the basis of that particular data, and how you can insert at the tail or at the last position of the linked list. So let's start with the head position. So again, uh, whenever you need to perform any operation on a linked list, just try to make a drawing of it and see how we are going to achieve our uh, our goal. So let's start. Like our first task is to insert at the head. So let's say I have a linked list with the four nodes again, and data is 1, 4, 9, and 16. And we have a head pointer. Again, quickly I will write the addresses, and this last one is null. Let's join them. So this will be 200 here, address of the next node, and head is having address 100. Now our target is to insert at the head position. So obviously you are going to have a new node here. Let's say the data is 15 and it is initialized, like the next pointer initialized to the null. So we need to fit this into the existing linked list. So how you are going to do it? So first of all, let's say this node has an address 600, and we need to insert at the head position. So what? So you will be needing two operations here. So the head is going to point at the new node, and the new node is going to point the whatever the head is pointing to. So these are the two steps we need to perform. So let's see how you are going to do it. So just two lines of logic to achieve this. First, whatever head is pointing to, we need to put in the let's say the name of this node is new node. So new node, what should the new node next have? So it should have a address of the our first node. So the address is 100, and this is the same that head is holding. So we are just doing this one assignment. So this step is done. Now we need to move to the second step. So what is the second step? Now head will be updated with the address of new node, and the updated head will have 600 as its address now. So simple, just two lines of code to achieve. So whenever you are doing some operation, just draw and see what links you need to rewire in case of insertion. Now let's take the another example. Let's say we have a linked list again with the four nodes. Quickly write the content of the next pointer, and this is your head. Let's say you need to insert a node here. Okay. So what do you need? First, you need this link because you need to rewire the link. And let's say we have a new node again. Uh, Rather, I will write here. Let's say that data is 10. And when we create a new node, the next will be initialized to the null. So again, let's say this is a current or a pointer that is pointing to this particular node. And this is your new node. So what is we have to do now? So the address of this node should now be next of the new node. And this should point to the new node. So we need to update the current next and the new node next. So new node next, what is a new node next? So we write new node next equals to, so if you see here, it should be equals to current next value because current next is the like this one. So we will say current next. Now the next step is we also need to update the current next. Okay. So current next will be your new node. So again, like two important line of code here. Just if you want to insert uh, at at a given position, or it could be like if you are given with certain data value. For example, if the question is like you want to insert a node after the node which has data as 9. So again, you have like same logic. So I will be covering more details when we do the uh, coding. Let's quickly see how to insert the node at the tail position. So again, like I quickly draw it. Now again, you need to create a new node. Okay. So here's your new node. and the next of this new node will be initialized to null. So what do you think? Like it is just going to be a um, one link or one line of code. So you just need to point this particular next pointer to this new node. So let's say this is your, like, you need to iterate till the last node. So the current, once you reach here, then current next equals to new node address. So, and that's all you have to do for creating the link. And I can, uh, okay, so the next thing is I want to cover the delete operation. So again, delete. So similar to the insert, you can delete a node at the head or at given position or at the tail. So again, like, we have a linked list of 4 elements: 1, 4, 9, and 16. This is null. This is your head pointer. This is 200, 300, 400. Let's see, now you want to delete our first node. So what do you think? You just need to rewrite the head. So the head will be start pointing to the next node. Okay. So first, like, for doing this, we will create a temp node of type node, and head will be assigned to this temp node. Then you just need to update the head. So head will be equal to head next. Okay. So head next is like 200. So you are rewiring this to 200 address here. And in last, you can clear this temp value. Okay. So like in C++, like we delete the nodes, but in Java, like, uh, we don't have to do this stuff. So that's the difference between like how we handle the structures, or the memory allocations in the C++ versus Java. So we don't do this in Java. Okay. So let's move to the second point, like where we need to delete a node that is at the position specified. Like again, we have a linked list with these 4 nodes. This is null. This is your head pointer. Now let's say I want to remove a node with data 9. So I am looking to delete this particular node. So this is something uh, like for achieving this, you need two things here. Like you need the previous node because now you need to rewire, and you also need a current node which you are going to delete. So what you need to do logically is you just need to rewire. So this like previous next, you need to update the previous next with the value of current node next value. Okay. So its current is 400 and this is this particular node. So this is how you can achieve the delete operation. Okay. And later you can remove this node. So there are like uh, obviously you need to run a loop where you need to run till you find the previous and the current one. Okay, so this will be something like while current data not equal to 9. So you need two things here. So firstly you will keep the previous node and then you will move further. Current is equal to current next. And at the starting your current is head. So you will traverse the linked list one by one and you will find the previous and the current nodes. Once you get the current and the previous, this is the line of code that will do the rest of the magic. Okay, make it so this line of code. Now the last part is we need to delete the tail value. So or the last value. This is your head having value 100 in it, and these are the next pointers. Now there are two things we have to do. Like first, we need to remove this node, and the second one is we also need to make it as null to mark it as the end of the linked list. Okay, so our first target is to reach till here. So if I say current, okay, and with the help of this current, I'm going to delete and reset the tail values. So the new tail will be, or the new last node of our linked list will be this. So I have to make current next equals to null once I am done with the deleting with this value. So before doing that, your current next will be, so like I will store in a temp, no? Let's say a temp and your current next. So your current next is having an address of 400 or the last name. Okay. And you can just remove this temp and set it next value to the null. So that's all you have to do while doing the insert operation. So that's all regarding the operations like delete, insert, and we started with understanding the linked list and finding the length of that linked list. Just to add more information to it, so this is a single linked list because it is having a single link. We also have a doubly linked list where we have a pointer or the reference to the both side. And we also have a circular linked list where we have a tail or the last uh, element or a node pointing to the head or the first node of the linked list. So I will be covering doubly linked list in the next video. I hope this video will be helpful for for you. Thank you.